Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 16, questions 47 to 49. And in this unit, we're going to take a look at some chemistry. So we've been given a table for some carboxylic acids with the general formula R, so carboxylic acid, and it shows the formulation of R groups and the value for property H. Now, the important thing here is that this unit it doesn't require prior knowledge in chemistry, it just requires a keen eye and pattern recognition. So when you read through this table, you should notice these. I've got a couple of points down here, but you should notice these points. So first and foremost, the H value of any carbon chain without a chlorine atom, is about 68. So you can see that. So ethanoic acid, propanoic acid. What else do we have? Butanoic acid. So if it doesn't contain chlorine, it's going to have a H value of 68. However, the second we add a chlorine atom to the chain, the H value decreases. But remember, if you take a look at the table, it's showing us that the chlorine atom can be in different positions in the chain. And what we see is that the chlorine atom attached to a carbon or directly next to the carboxylic acid group, so to the right, if you take a look at the R groups, so to the right is where the carboxylic acid is, the H value drops by about 23. So you can see that in chloroethanoic acid. You can see that in, we've got 2-chloropropanoic acid. You could see that in 2-chlorobutanoic acid. Same idea. So the closer you are to the carboxylic acid, it's going to drop by 23. However, if you shift that chlorine atom further from the carboxylic acid, the H value increases. And in this instance, you can see between 2 and 3 chloropropanoic acid and 2 and 3 chlorobutanoic acid, it jumps by 15. And finally, if you move along once more in the carbon in the chain, so instead of going 2, 3 now, the chlorine is 4 times away from the carboxylic acid. So you can see, for example, in 4-chlorobutanoic acid, this raises the H value by another 5. So I've kind of put a little summary here. The whole point, I think the most important thing to understand is the further away the chlorine atom is from the carboxylic acid. So I've got an example here of 4. So 1, 2, 3. So we've got 1, 2, 3, 4 chloro, 2 methyl butanoic acid is going to have a greater H value than our 1, 2, 3 chloro, 2 methyl butanoic acid. So that's something important to note. So now if we take a look at the first question, 47. So remember our key rules to follow. It says, which of the following is the best estimate for the H value for 2-chloropentanoic acid? So, two things we have to note. If it's a pentanoic acid, just pentanoic acid alone, that doesn't have a chloro group, well, it's going to definitely be about 68. However, because we added chlorine to the group, and because it's a 2-chloropentanoic acid, so if we say, let's just assume this is a pentanoic acid, 1, 2, it's close to the carboxylic acid, which means it's going to drop by, which we've seen in the table, about 20. So that means the answer for 47 has to be about 68 minus about 20, 23. So it's going to be about 45. So the answer has to be A. The closest is A, 46.1. So now if we take a look at question 48, it says, which of the following is most likely to have a value of H closest to 60.7? Now remember, if we take a look at the table, all our compounds that have a value of around 60, they're the ones where the chlorine group is at least 3. So you've got the carboxylic acid, so 1, 2, 3. So it's on the 3 end of the carboxylic acid. So it's not about carbon chain length, it's about the distance from the carboxylic acid. So if you want to get a value of about 60, it has to be a distance of, so it's going to be 3. So it's going to be 2 carbons away from the carboxylic acid, which is the 3. So that means the only one that satisfies this has to be A. So 48 has to be A. It's going to be 3-chloropentanoic acid. If we were 4-chloropentanoic acid or 4-hexanoic acid, it's the same idea. It's going to be about similar value because it's not about the length of the carbon chain. It's about the distance from the carboxylic acid. So if we had a 4-chloropentanoic or 4-hexanoic or 5-chlorohexanoic, the value is going to be greater than 60. So the answer, well, the value for 5-chlorohexanoic is going to be greater than 4-chlorohexanoic, which is greater than 3-chlorohexanoic, or pentanoic in this instance. So that's why the answer for 48 is A. Now, if we take a look at question 49, the last one, now this is about trying to not trick your brain. This is a bit of a brain teaser. It says, which of the following is most likely? So you have to comprehend what's being said here. The value of H. So remember what we said. The further the chlorine group is from the carboxylic acid, the greater the H value. So if you just use your eyes here, keen eye, it should be, if it's 3-chloro, it should be, so for A, it says 3-chloro, 2-methylbutanoic, 2-chloro, 3-methylbutanoic. So 3-chloro has to have a greater H value than the 2-chloro because it's further away from the carboxylic acid. So it says A, 3-chloro is less than 2-chloro. That's incorrect. B says 3-chloro is less than 4-chloro. That's correct. C says 4-chloro is less than 2-chloro. No. It's going to be more than. And D says 5-chloropentanoic acid is less than 3-chloro, 3-methylbutanoic acid. Again, no, it has to be more than. So that's why B is the answer. And I think a lot of students get tricked here because they think two different compounds. But remember, the rule is it doesn't matter about the length of the carbon chain. It's about the distance of the chloro group from the carboxylic acid group. So from the terminal carboxylic acid group, the distance from there is going to determine the H value. So that's how we answer these questions. Now, if you're still having trouble trying to piece together this puzzle, you can post your queries in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.